All right, this is part one of managing data in SAS. The first thing we're going to go over is using the sort procedure to reorder observations in place or output to a new data set with the out equals option. So we're going to use proc sort, and we're going to use the data set maps.africa. Create a new file called work.test. Put a semicolon, and we're going to sort by the density variable, and then we're going to run it. Let me just show you what's going on here. This is the maps.africa dataset that we've been using throughout most of these videos. And we're telling the program to copy all this information and put it into our work.test dataset, except the only difference is that density is going to be sorted ascending. So let's go ahead and run this. And we can see density is now sorted ascending. So the other way to do this is to just edit the file you're working on instead of creating a new out file. So we'll use proc sort again, and we're going to say data equals work.test, which is the file that we just created. And we're going to sort it by density again. So this time we're going to sort it descending. So by default, when you sort with a by statement, it's going to be sorted ascending. If you want to change that, you just use the word descending before the variable that you want to sort. So on this, and we can see everything's the same except density is now sorted descending. So that's not too terrible. Let's go ahead and comment this out and move on to the next one, which is removing duplicate observations with the sort procedure. So using proc sort again, I'm going to use maps.africa, and we'll go ahead and keep on with the work.test out file. And this time we're going to use a little phrase called no dupe key. And we're going to say by density again. We'll run it. And all this is doing is it's looking through maps.africa and returning all the unique values of density to our work.test dataset. So we can see here, this is maps.africa with only unique values of density. And this will look at the first observation that the program runs through. So it just depends on how you have it sorted. So the other thing you can do with this, because this might not always be useful just to sort by one variable, is you can use underscore all underscore. And what this will do, it'll look through observations that are duplicated across every single variable. So it looks for true duplicated entries. We'll go ahead and run this. You see we've got maps.africa, and if we go to the log, we can see that there was one observation with duplicate key values, and it was deleted. So not too terrible. The only thing that's different there is we're adding no dupe key. So let's comment that out and move on to the next one, which is using if then else statements to process data conditionally. So for this one, we're going to create a new data set called cheese color. We're going to input our own values. So we'll create a variable called cheese and we'll say that it can be anywhere between 1 and 31 characters. And our second variable is going to be color. So that can be anywhere between 1 and 10. So let's cut this out so we can see what happens, and then we'll come back and paste it in later. All right, So we're going to start with our if statement and say if cheese equals Swiss or cheese equals monster, then color equals white. We'll do a semicolon there. Now we'll say else if cheese equals American cheddar or cheese equals Colby and color equals yellow. We'll do a semicolon and we'll come down here and input data. If the data lines, you want to make sure you get your cursor all the way to the left or else things can get a little weird with the data line statement. So we'll say Swiss, enter, monster, enter, American cheddar, enter, Colby. Do a semicolon to end it and check the log, no errors or warnings. And you can see that the program followed our logical conditions. So Swiss and Munster got assigned a color of white, and American cheddar and Colby got assigned a value of yellow. And you'll notice the W is missing here on the yellows, and that's because since we didn't assign a length for the color variable, it automatically assigned it for the first entry it saw, which was white, and it has 5 characters. And you can see that W gets cut off as it's the 6th character. So all we've got to do to fix that is do color and say specify a length for it. So we'll run that and it should be fixed. And then just to explain what's going on here, if you haven't messed with if then else logic before, all we're doing is telling the program to look at our observations, and if cheese is equal to Swiss or Munster, then assign a value of white to the color variable. And if cheese is equal to American cheddar or Colby, then assign a value of yellow to the color variable. So nothing too crazy. It's kind of intuitive. Just have to get used to it, I guess. So the next thing we're going to go over is using do and end statements to execute multiple statements conditionally. So we're going to create a new data set called test do. And input our values. So our first variable is going to be called years, and it's going to be 8 dot, which means that it's numeric and it can have up to 8 digits, and we're not going to let it have any decimals. Our second variable is going to be months, and we'll do the same thing. Now we're going to say if years is greater than 5, then do. And then every do we want to close with an end. And everything that it's doing is in between do and end. So we're going to say months equals years times 12, semicolon, and then put years equals months equals semicolon. What we're telling the program to do is if the value of years is greater than 5, then do the following thing. Assign a value to months that's equal to years times 12, and then put the value that we just calculated into the months variable and put the value of the years variable into the years variable in our output data set. So next we'll come down here and say else if years is less than or equal to LE 5, then do years times 12, and let's just say plus 1. Then put years equals months equals, and then we'll end that do. And then we've got to put in our data. So use data lines again. Just say 6, 7, 5, 5, 4, semicolon, and then run this. So we can see that the programs followed our logic. So 6 times 12, 72, 7 times 12, 84, and then since 5 and 4 are less than or equal to, does times 12 plus 1. So we're combining the if then else that we just learned with these little do end statements. All right, let's move on to the next one. And I think we're going to cut this because there's some overlap here. So the next one is create a new variable and assign a value. So if we want to create a new variable and assign a value in a single statement, we can do that. So let's do that with months here. So let's delete it, run it. You can see that everything works fine. And that's because in this line of code right here, we created the months variable and assigned it a value, or here, if the logic hit here first. So all in one line of code, we created a variable and assigned it a value. Nothing too crazy there. So the next one is assign a new value to an existing variable. So to accomplish that, all we have to do is add months back, save it, we'll run it. Everything works fine, no errors or warnings. So what we did here is we have a variable that exists already, months, and then in our statements, we added values to those variables. So not too bad. Comment that out. Actually, using this in the next one too. Yeah, so assign the value of an expression to a variable. So this years times 12 is an expression, and we assign the value of that expression to the months variable. So nothing crazy there either. All right, next one, we're actually doing something. We're assigning a constant date value to a variable, which we've done in a previous video, but we'll go ahead and do it here too, just so we're covering it and it's all this, we're on the same page. So we're gonna create a new data set called sample data. We're gonna input our own data here again. And we're gonna create a variable called date1 that is in this format. And then another variable called date2 that is in this format. And we're gonna add our data in here, data lines. We'll just do today's date twice in the 2 separate formats. So 23, 06, 20, and 23, 06, 2020. And then save our program and run it. So, oops, something went wrong here. What did we do? let's see. Oh, forgot a space. All right, let's try that again. All right, something's getting funky here, so we'll just do one variable just so we can move on. All right, we put today's date and assign that to the date one variable, and we did that by telling the program to look at position one of the data that we entered and start there. Um, 1, 2, 3, 4, 5, 6, 7, 8. 10. Oh, that's what we did wrong on the other one. We used the wrong pointer, but whatever, we'll move on. So we created a new variable called date one, apply this in format to it, which says that it's day, month, year format, and it's 8 characters long. And then we assign today's date to it. So nothing too crazy there either. Next thing is change the names of variables by using the rename equal dataset option. So here we are going to create a dataset called rename one, and our variables are going to be A, B, and C. Then we're going to add some data, and we'll say 1, 2, 3 for the first observation. The second observation we'll do 4, 5, 6. And then we will end it there. Go ahead and print this out so we can see it nice and clearly. Proc print data equals rename one. So we created a table with these three variables, A, D, and C, and then these random entries just for the sake of having some data. So if we wanted to rename these variables to ABC rather than ADC, we'd come down here, do another data step. We'll call our new data set rename 2. This time we'll do parentheses, specify our rename option, say equals, and parentheses again. And all we have to do here is say D equals B. Closing parentheses. And set it equal to rename 1. And then let's do a proc print here again. All right, so this is our rename 1 data set, and this is our rename 2 data set. And you can see we changed the name of that second variable from D to B. So pretty easy, and that one's kind of intuitive too. The next one is use the label and format statements to modify attributes in a data step. So we'll create a new data set, format 1, we'll set it to Africa. We'll format long variable to a value of 82. And we will add a label to the long variable. 82. This has been modified. Semicolon. We'll run that, but just so we can actually see what we're doing. We'll do contents of data at 1, and then another one, so we can see the difference. See what happens here. All right, syntax error. Where did I mess up? Expecting one of the following: a name, let's look this up on the documentation really fast. And then while I look that up, I'll pull up our output. All right. Oh, I forgot the semicolon right here. Yeah, that's an obvious one. All right, that's good. All right, no errors or warnings in our results. So this is our work.format1, and here are all of our variables. You can see long now has a format of 8.2, and the label is this has been modified, whereas maps.africa doesn't even have a specific format, and the label is unprojected longitude in radians. So that's how you update the label and the formatting. Not too bad either. So we'll go ahead and comment that out. The next one's kind of similar. We're defining the length of a variable using the length statement. So this time, let's use another data set. Let's say SAS help baseball. And run. Just see what this data set looks like. Oh, the data. Sorry, I'm messing up a lot today, but that's part of it, I guess. All right, so this is our SAS help.baseball data set, and we are going to be editing the length of one of these variables. So let's go ahead and do div. So you can see right now the length is 16. We're going to change that. So we're going to create a new data set called length 1, and we're going to change the length of our div variable, and let's just say 17. So it's 16 right now, we're changing it up 1 to 17. So we need a semicolon there, and then we're going to say set SAS help baseball, and then we'll run it. And we'll do contents. Our new data set, data equals length 1, and we'll run it. All right, so this is our SAS help.baseball, div is still 16, but then our work.length1, div is 17. And then an important thing to note on this one is length has to be before the set statement, because if not, you get this error. But after set, and we run that, our log will give us a warning that says length of character variable div has already been set. Use the length statement as the very first statement in the data set to declare length of a character variable. And if you come to the results, it shouldn't have changed at all. So yeah, div is still equal to 16. So it just skipped it. So we always want to make sure that we have length first before we set it equal to another data set. That's all I've got for this video. I'm going to have part 2 coming out here pretty soon. If you have any questions, let me know. Thanks.